Okay, I wanted to start off today by making sure everybody is aware of what's happening in the Atlantic Basin. There are actually two storms. There's a smaller one down here, and they're headed this way probably around Tuesday. So pay attention to the news over the weekend. The forecast is likely to change. But it's possible that we might not have classes next Tuesday, depending on how bad these storms turn out to be. The Nichols webpage is a good place to let you know what's going to happen with the university. And they'll update that and send emails throughout the weekend. Any questions about that? Okay, so today we're going to lecture about chapter 4. Chapter 3 quiz is due tonight by midnight. Between the two groups, I've only had 5 people try it so far. So please be sure you go ahead and do that today. With chapter 4, we're going to be talking about the flow of food. And for the next several chapters, we're going to go through each of the steps throughout the flow of food. So when we're talking about this is the path that food takes when it goes through your operation. It starts with who you're purchasing the food from, what you do whenever you receive the food, how you store it, how you prep it, how you cook it. After you cook it, you might cool it. Question? Yes. Turn it to the next one, and it'll be chapter 4. So whenever you watch chapter 3 online, you can follow along with it that way. Okay, so we're cooking it. After we cook it, it's possible we might cool it off to reheat later or hold it somewhere. And then there's a process for reheating it and a process for serving the food. So throughout all of these steps, we want to make sure we can prevent time temperature abuse and cross-contamination. Okay. So one of the tools that we use to prevent cross-contamination is separate equipment for raw and ready-to-eat foods. Okay, so we talked about minimizing bare hand contact with ready-to-eat foods. You might have like a certain color tong that you use for baked goods or things that are done cooking, so that's in everybody's mind. If it's the one with a brown handle on it, that usually means that it's cooked. In the photograph, we have a cutting board, and it is a yellow cutting board. We have probably about 6 different colors of cutting boards, and yellow in this case is assigned to poultry, blue would be assigned to seafood, red is for raw meats, and brown would be for cooked meats, and then you have the green for vegetables, and then white for like any type of dairy product, cheese that you would need to use. But there should be a sign posted in the kitchen that explains what each color is used for. Also, to prevent cross-contamination, we clean and sanitize. We clean and sanitize all the work surfaces, the equipment and utensils before and after each task. So at the start of the day, you clean and sanitize, you do a job, you clean and sanitize, and then you move on to another job. Some things that you can do. If you have a small kitchen and you just have one prep table, you you would want to be doing things separately. So if you had chicken and vegetables to work with, you would process the vegetables separately from the chicken. And ideally, you would process the vegetables first, clean and sanitize, then do the chicken, so you don't have any chance of contaminating that ready-to-eat food with anything from the chicken. Another thing that you might do is buy prepared foods. So things like cleaned and shredded lettuce that's already been processed minimizes the amount of time that you have to work with it. You will not have to go and wash it, clean it, chop it up, throw away the scraps. So there's less of a chance that it will become contaminated with things like raw chicken. Okay, we're also concerned about preventing time temperature abuse. The temperature danger zone, I think we've talked about this, between 41 degrees and 135 degrees Fahrenheit. Okay, the food has been time temperature abused. It is held in that temperature range between 41 and 135 for there's a number of hours. Does anybody know how many hours it has to sit at the temperature danger zone? 4 hours. Okay, good. If you cook food to the wrong internal temperature, so if you cook chicken to like 120 degrees, that's nowhere close to what it needs to be cooked to. If it's held at the wrong temperature, so if you cook something, any TCS food, so it could be chicken, any kind of meat, baked potatoes that are wrapped in aluminum foil, and you leave that sit out overnight to cool off, that's time temperature abuse. Cooled or reheated incorrectly. In one of the coming chapters, we're going to go through all the steps involved with cooling food correctly and reheating food correctly. So to avoid the time temperature abuse, we're going to monitor how much time we have food out in the temperature danger zone. And it's not like in some cases you might keep a log of like when you started working with a batch of something, but you want to make sure you have the right kind of temperature or thermometers available to check temperatures of things. We've got quite a few different types of thermometers that we'll talk about today. You'll regularly record temperatures and the times that those temperatures are taken. Minimize time the food spends in the temperature danger zone. So if we had like 100 chickens that we had to chop into 8 pieces each to do fried chicken, you wouldn't pull all of those chickens out of the cooler at one time. You'd only take out as much as you could work with within maybe 30 minutes. Go ahead and process those, get them back in the cooler, and then take out another tray to work with. That way you don't have 100 chickens sitting out at room temperature while it takes you the time to do that. Take corrective actions if time temperature standards are not met. One of the easiest things to do that. Poultry has to be cooked to 165 degrees Fahrenheit. So if you check the temperature of it and it's only 155 degrees, what do? You throw it away? What makes sense to do if it's only 155 degrees? Cook it longer, yes. Okay, that's all. It's not that bad. Okay, so one of our important tools that we use in the kitchen is called a bimetallic stemmed thermometer. Okay, it measures the temperature through a metal stem. This is the sensing area it's got a pointed tip and about 2 inches up the stem. It's got a little indentation or a dimple. That is the sensing area. That entire sensing area has to be inserted into the food. So this is typically used for something like a beef roast or a pork roast or a turkey, something that is big enough for you to insert that whole sensing area into. Up near the top, it has a calibration nut to keep the thermometer accurate. We're going to talk about how we calibrate those in the next couple of slides. After we talk about the different types of thermometers that we have. Okay, so in addition to the bimetallic stem thermometer, we have thermocouples and thermistors. It looks like a big cell phone type of a thing. It has different probes that can be attached to it, kind of just like a USB attachment onto it. And then, let's see, it shows the temperature digitally. This probe, can you tell what the thermometer is in that little container? Can you tell what he's taking the temperature of? Kind of hard to see. That's ice water. There's a reason why you would take the temperature of ice water. And that would be an immersion probe. Immersion probes are used taking the temperature of liquids. We also have a surface probe, which is kind of a little flat disc. You can put it down onto like a cast iron pan or a griddle and get the temperature of that surface. Penetration probe is similar to the bimetallic stem thermometer. It's got a point on it. It's going to go inside of food. And they also have air probes, which will take the temperature of the air. We also have infrared thermometers. Every time you walk into a building on campus, there are some posted near that entrance. They're pretty much the same thing as what we use in a kitchen to take the temperatures of surfaces of food and equipment. So it's not going to be able to tell you what temperature that bag of lettuce is in the photograph in the middle of it, but it can tell you what the surface temperature is. I'm going to hold the thermometer as close to the food or the surface as possible. Remove anything that is between the thermometer and the food package or equipment. If anybody has bangs in here, you might have to pull your bangs up to get your temperature recorded. Can't see if anybody has that issue. I haven't in some time. Follow manufacturer's guidelines. You're going to see that a lot as a thing to do with any type of equipment. We have another type of thermometer called a maximum registering thermometer. It indicates the highest temperature that is reached while it's being used. And we use it in places where temperature readings cannot be continuously observed. You know, we haven't really talked about it too much, but the place that you would use this is in a high temperature dishwasher. Your water has to be a certain temperature in the final rinse in order to be able to sanitize it. And it's not really easy to take the temperature of that water. So you would attach this to a rack that's going through the dishwasher, and it will register the highest temperature recorded as it went through there. There's also something called a time temperature indicator. This is something that the people that are selling you the food will put on the package before it is shipped to you. So it monitors both time and temperature. So that it's going to get different colors the warmer that it gets and the longer that it stays at that temperature. So whenever once it reaches that color, it doesn't disappear if it cools off after that. So when you see that it's reached a color that's like orange or red, that's going to be something that you know has been time temperature abused, and you would want to return that. Okay, whenever we use thermometers, you want to wash, rinse, and sanitize them both before you use them and after you use them. So you don't want to take any chances that you're getting any type of pathogen on that thermometer, or that there is any pathogen on it that you would introduce into the product that you're testing. We're going to calibrate them very often. Anytime they've been bumped or dropped, after they've been exposed to extreme temperature changes. So if you were checking something that was frozen and then you had to quickly go check something out on the grill, it would be like a 200-degree temperature change. That could throw the thermometer out of calibration. You want to calibrate them before food deliveries arrive, because part of the receiving process is going to be taking temperatures of TCS food when it comes in. You should do it before each shift. So every day before you go into your kitchen or start your job, that's part of your preparation list. Calibrate the thermometer. So we want to make sure that we are using thermometers that are accurate when we're using them to check food. And this will be on the directions that come from the manufacturer. It's got to be accurate within 2 degrees plus or minus. And then if it's checking air temperature, like something you might hang in a cooler to get the temperature, it has to be accurate within 3 degrees. The only time we use glass thermometers is if they are enclosed in a shatterproof case. Pastry chefs often use glass thermometers whenever they're boiling sugar, because as sugar boils, the temperature goes up and it reaches different stages of hardness that will do different things the hotter that it gets. And it's a lot easier to use a glass thermometer. Also, when using a thermometer, like they're taking temperature of a roast in this photograph, you got to make sure that you go into the thickest part of the food, because that's going to take the longest to cook. If it's a really big item, take the temperature in at least 2 different places. You have to wait for the thermometer reading to steady. It might take 15 to 30 seconds maybe. Okay, when it comes to calibrating thermometers, we have what we call the ice point method. It's the first method. You take a container and fill it up with ice, and then you add cold water to it. You put your thermometer into the ice water, let it sit there for 30 seconds, and what temperature should it read? It should read 32 degrees Fahrenheit, because that's the freezing point of water. So if it doesn't reach that temperature, you take a look in the second photograph here. The case that the thermometer comes in has a piece on it where you can put the thermometer into it, hold it in place. It actually fits over the calibration nut, so you can just turn the top of the thermometer until it reads 32 degrees when it's in the ice water. There is another way to calibrate a thermometer. There's another temperature of water that is consistent, and that's at the boiling point of water. Anybody know the temperature for boiling water? Can't hear anybody. It's 212 degrees Fahrenheit. And if you're, it's the same kind of thing. If you have that in the boiling water for 30 seconds, it should read 212 degrees. And if it doesn't, you adjust it until it does. Now there are, this would be the analog version, like the clock on the wall is an analog as opposed to a digital that reads out the numbers to you. If you have a digital thermometer, you have to follow the manufacturer's instructions as to how to recalibrate it. And a lot of times, those digital thermometers cannot be recalibrated. And once they go out of calibration, you have to get another thermometer. So really the older type of thermometer is really easier to keep and adjust as you need it. And when I was working with thermometers, if I were going to take the temperature of something that was relatively cool, I'd calibrate it to the ice point method. But if I was going to take the temperature of something that would be really hot, I'd calibrate it at the boiling water temperature of 212. That way I wasn't shocking the thermometers. I went back and forth. Okay, this is the last screen on chapter 4. So we're almost halfway through the textbook. How many of you have the textbook? Anybody have it with you here today? Anyone here? Okay, great. When I'm writing the quizzes, I'm going into the textbook and writing the questions based on the text. So you're going to see some things in the quizzes that are not necessarily in the PowerPoints or the lectures. Please let me know if you have any questions about the about things that you might have missed on any of the quizzes. Did we talk about elderly? Like what defines elderly? Was that in this section or was it the other section? It was the other section. Okay, so how old is elderly? I can't hear. 65? Okay. Does everybody agree 65? I still agree at 65. I still have like over 5 years to get there, so I don't feel like I'm elderly most days. But the one question on the quiz was about who was it considered at high risk, and I had to put down like a 55-year-old grandmother, and that's not the right answer, especially since there was a transplant recipient also on the list. That's a much higher risk population. Whenever this class gives you a question, it's always going to be pick the best answer. And technically, it's possible for a 55-year-old person to have a compromised immune system, but when they're described as a 55-year-old grandmother, you can't assume that anything else except that it's a 55-year-old woman. And there's no reason that an average 55-year-old woman would be at a high risk for foodborne illness. In the news this week, there's another salmonella outbreak. Has anybody seen that? Okay, turns out fresh peaches have salmonella on them. I haven't found out yet how that happened, because that's really unusual for a tree fruit to have salmonella on it. I'm assuming that at some point in their processing, they came in touch with contaminated water. But typically, like a flood water would not reach peaches up in a tree. So somewhere they were run through a bath that had salmonella in it, as best as I can tell. But it's you can put alert on your media feeds. Look for foodborne illnesses, because they happen a little bit more than you're aware. And you want to make sure you're not eating something that is known to have a problem with it before it gets recalled. Okay, questions? Anybody have a hurricane plan in case that storm comes? batteries, bottled water, someplace to go if you have to evacuate. Okay. They will have, in the case that it's a bad storm, they will have evacuation areas, either on campus or a way to get to them. And just, watch your emails, watch the Nichols website, watch the news, see what's going to happen. It could just be a rain event by the time things get here. And you'll hear it everywhere if it's going to be serious. So let me know, email me if you've got questions or if you need help with something. There's a lot of resources on campus to help people that don't have somewhere to go when this kind of storm or a strong storm comes through. So just want to make sure everybody stays safe, and I hope we see you on Wednesday. Okay? Righty, have a good weekend. Quiz free tonight.